Hey, what's going on, guys? Gomagiginzi here. I have amazing news for you guys. So I've just passed the perf test for two positions, the standard, the initial position of Xiangqi, and also some sort of a fantastic equivalent of so-called tricky position in international Western chess. Absolutely amazing one. And I've revealed only two bugs within the move generator. It seems like there are no bugs within the e-square attack function, believe it or not, which is quite pretty fascinating. So in this video, I will first fix this bug in the master branch, basically. So I will do this just right now in the moment, highlighting what in particular was going wrong there. And then I would like to share the way how I was debugging the move generator. So I've already provided make, move, take back functions, encoding and decoding moves, and perf test routines. And also I was using somewhat another engine, not the one I was going to use initially, because that was buggy as well, so it wasn't really passing the perf test properly, but another called Chameleon, which is really nice. I've managed to compile that on Linux. It has a standard build for Windows as well, by the way. So, but I needed to go for some sort of a hack to enable the perf test in there, because by default I didn't really find an option to do that. So just really wanted to highlight this tiny little details, because that's the absolutely essential practices regarding the matter of debugging the chess engine itself. So without further ado, let's actually start. So I didn't, probably there is no reason really to run the code, but well, let's still try this. So we're not gonna see much really here, but okay. I could have shown you the buggy positions, but well, probably, I don't know, maybe that should be done. Okay, so let me just really better walk through the positions. So starting from this one, copy, just to show you how the issue looks like. So, no, just hold on a sec. So I want to set the board, generateMoves. Okay, print board. Okay, so let's have a look. So now the problem is, no, hold on a sec. The problem is that I have slightly wrong code. Okay, so let's try this. Okay, so here we generated moves for rack cannons, and the issue moves here, the moves that shouldn't be available, is move D2 to A2 and B2 to E2. So you see, like B2 to E2, this move is illegal, right? Because we're not searching for the condition that after the jump over flag, we need to make sure that we capture a piece and not landing on an empty square. So this is the first bug, and another would be related to the bishops. And the same stuff like D2 to A2, just let me find the move quickly. Yeah, D2 to A2. So these two horrible bugs were producing the wrong, completely wrong, malformed perf results, unfortunately. But now we can simply fix that by, well, actually generate moves. Oh yeah, here I didn't even add the print move list stuff, so we can only see them in the console, but doesn't matter really. We'll just now see how they disappear from there. So we need to go to, here is my by the way, I found some perf results, which is not really that trivial to, which wasn't really that trivial, to be honest. Only in some sort of a Chinese sources I managed to get this. Well, okay, I will probably highlight this when it comes to perf testing, and now let's focus on fixing the bugs. So we want Canon capture. Also, yeah, I've been kindly pointed out that I was writing the word Canon in the wrong way. So there should be double n instead of one, and I didn't know that, sorry for that. But now all the Canon word within the source code, whether this is the variable or constant or the commentaries, that has been fixed as well. Okay, so okay, I want to Canon capture. Yeah, here it is. So here are the conditions for Canon capture. So we need to make sure that, so this is the very first condition that has been added. So here, find Canon capture. Excuse me. Oh, it's because here is still, hold on a sec. Can be, or it's just not been mentioned. Okay, let's just find generateMoves. Yeah, generateMoves. Capture Canon moves. It's better to call it. Okay, capture Canon. Quite Canon moves. Capture Canon moves. Okay, just doesn't matter. So here we did only check for, so piece type is Canon, hidden opponent's piece, and I thought this condition is enough, but it wasn't so for some reason. And also jump over equals to 2. So an extra, by the way, I'm just wondering, piece color of the target piece. Hold on a sec. This is already fixed, but I just want to have a quick look at the colors. So that was the color of. Well, that's a little bit strange, probably needs a little bit more research, but yeah, let's better focus on fixing this stuff. So here we didn't change, we didn't check for the target piece. Okay, here, right? So we needed to make sure that the target piece is actually equal to true. Okay, because, well, otherwise it's just, so it's not an offboard definitely, but we need to make sure that that is equal to true. So here we do this. So this little condition. So I just copy this and paste here. And now this moves B2 to E2 should disappear, as well as D2 to A2. This one and this one, this one and this one, they should disappear. So if I update the generator, B2 A2, yeah, B2 B3, so they have disappeared, right? Okay, so B2 A2, B2 B3, B2 B3, and going upwards, so on, D2 E2, not B2 E2, but D2 E2. This is correct. It's now going D2 to A2. So let's check this. So D2 territory here, none of them go into A2. So this is correct. So the first bug, and another bug was I just forgot to check for if bishop jumps over a piece or not. So if we just have a look at the position, like, just quickly draft some for you guys. So, well, let's consider just some imaginary position. So let's say 2 bishop and what else? 2, 3, and 9 minus 3. Oh my god, 6. Yeah. So, okay. Not exactly the place, but okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, this should be rank 10. Like this. Okay. And now let's put a piece on D2. Okay. Oh, on D1, sorry. So we'll say 3, and let's just put, I don't know, whatever piece there, and 4, and this is 5, right? Okay, so now the problem is, as you can see here, so it generates moves C0 to A2, which is correct, and also C0 to E2, which is horribly wrong because bishops can't jump over another piece, no matter own friend or foe color. So this is another issue. So now we'll fix that as well. So rooks, cannons, knights, bishops. So the first line to add, I'm initializing the jump over square. And hold on a sec. My computer hanging. Hold on a sec. Okay, so just reloaded my code editor. Something has gone horribly wrong. So I'm going to bishops. So where are my bishops? Okay, again, generate moves and bishops here. So I need to initialize so-called jump over square. So you remember, like, bishops are diagonals multiplied by 2. So let me just quickly demonstrate you that. So here we have the diagonals: up left, up right, down left, down right. And bishop move offsets like up left multiplied by 2, up right multiplied by 2, down left multiplied by 2, down right multiplied by 2. So the feature of interaction between bishop move offsets array and diagonals array, that the directions are exactly the same. So having the same index, we would be getting exactly the same direction. So if bishop goes up left, so we can reference diagonals by the direction index. So let's say 0 up left, and in that case we would be generating move up left multiplied by 2. So we need to make sure that so these diagonals is like kind of only one square. So bishop is kind of 2 squares, and this is only 1 square. So at this 1 square there shouldn't be anything. So that's the way how we can make sure that bishop is not jumping over a different piece or whatever piece. Okay, so first we do need to initialize this. Oh my god, we need to initialize this jump over square. This is it. Okay, and the next thing is this little condition. So we need to make sure that board zones, not only within the board zones, but also the jump over is equal to empty. Otherwise, we're not allowed to push the move. So that's a very simple hack to make sure that the move generator, now I can say that it 99% bug free. Well, obviously some weird disaster always can happen, but at very least now I feel like this should be working. And I'm incredibly proud of this implementation, to be honest, because also, by the way, it's at very least it's not slower than my Wukong.js for international Western chess. Probably even a little bit faster. We'll see that. So I will see the estimate for nodes per seconds to make sure. Okay guys, so this is it regarding the updates. So make sure to either download the source code. It would be updated after this video being published on YouTube. And also, I don't know where it would be better to highlight these ideas regarding the perf testing within the perf test itself. But no, probably as far as I have the inspiration now, I will now show you this, guys. So the very first thing that was incredibly difficult to come up with actually this perf values. So here I've managed to find them in the source code of one of the engines where in README there was everything in Chinese, but I've managed to extract this gold data from there. So we have the number of nodes. We don't need check and captures, really, just the number of nodes. So how many nodes the move generator should be traversing for initial position, and also how many nodes it should be traversing for this like CNC variation of tricky position. I just really want to show you this position is really complicated, but it's incredible. It's really incredible. So I just really want to show you this position now. So have a look. So this is how it looks. You see like lots of cannons. Canon can be going to different places. Also possible hidden checks, etc. So say rook can go here because it would be a check from the cannon and so on. So really complicated position, and surprisingly I've managed to pass the perf test for up to depth. Here up to depth 5. I didn't check depth 6 here because it takes really too long, but I think that is, if it were listed here at depth 5 we're okay, and at depth 5 here we're okay as well. This is really kind of fun, kind of enough there. Could have not been included in this part. Could have done this just to make it a little bit more symmetrical. So yeah, I'll take a decision a little bit later about this point. Okay guys, so what else did I want to say? Yeah, this one is available on some sort of a website. I forgot already now, but this one is absolutely unique. So the next issue, sorry, the next challenge was to find an engine, a CNC engine that is actually capable of running perf tests separately. And the one I was using before, which is the CNC.js library for CNC, it appeared to be not passing the perf test. So already within the starting position, starting from the depth 3, it fails to pass the perf test. So that's kind of buggy and it's not working. That's just really bad for it. I don't know, maybe I should open an issue on GitHub there, but not sure if that's the good idea really. But anyway, so eventually I came up with the following solution. So I've downloaded this Chameleon chess engine by, oh my god, I forgot the guy's name. It's not a name, it's like some sort of a couple of words, not like first name and last name, just a couple of words. Just forgot that. Just let me try to reveal that back if possible. So Eater Cyber, yeah, this is the guy. So he derived his engine from Stockfish and just made it plain CNC, which is really fantastic. So and I've compiled this, and also I've changed the source code a little bit, so now we can actually not go in for UCI loop, but instead just initializing the position to whatever EVN I want, bring the board to screen, and search and run the perf test at the given depth. It was really horrible to come up with all of this C++ synthetic details, because I hate C++ really, and I hate it even more after this horrible experience. In order to write four simple lines of code, so literally 2 simple lines of code, I've spent around 2 hours, just because I have no idea like how to make sure that the type of variable is equal to user-defined variable, which is defined as the enum. Yeah, that was really tough. Also, I had no idea how to use these damn templates, which I also hate at the moment already, because it's so complicated. I just want to make a simple thing, and I was forced to dive into damn C++ deeply in order to figure out how to make a very simple thing that I wanted to do. But anyway, thanks to Chameleon, it's not the matter. It's not the fault of engine or of the author. It's just the matter of language. But some people prefer C++, and that's totally fine. But I'm not one of them. So anyway, I've managed to compile and run the perf test for this of this engine, and I can probably even show you this quickly. So just open the terminal here and just make and run. Okay, not here, sorry, here. It also has Windows right over in here, so it's done in Microsoft Visual Studio that I had as well, but it has a normal Linux makefile, fortunately, but also probably can be compiled from Microsoft Visual Studio as well. I never used that, so I can't say for sure. but it seems like it was developed under Windows eventually. Not eventually. At first, well, initially, not eventually. Initially, seems like was developed under Windows. So, and here we got the perf test depth 1 for this position. They have a pretty printed board here, so we just increase the number of nodes. Okay, I already shut that down. Main. So let's say depth 3. Save. So it's incredibly important to have kind of big brother who has a bug-free move generator to compare the nodes, the number of nodes, the number of old nodes as well. So that's kind of it. So then what I was doing, so I had two lists, one list produced by this Big Brother engine and another one that was produced by my buggy engine. At that time it was buggy. So I just stored the results engine here. So I just stored the correct results from that engine. Well, I didn't start with the depth 1, so first I was comparing at depth 2, I guess. Yeah, then I went to depth 1 to narrow the scope where the bug exists. And then I compared this with my run results, this one. So I've extracted just the move and the number of nodes using Python. So I've created a little Python routine just to extract the move and nodes and compare. So if we have the same move but the number of nodes is different, in that case we need to fire all the moves that are kind of wrong. And in my case that was literally 28 moves of 29. That was really horrible, but fortunately that was just a matter of a single bishop issue after I fixed the initial one with the Canon attacks. So then when I had only a different number of moves at the depth 1, so here I had oh my god, I don't remember how many I had. So I had 30 moves in the run, and I had 29 moves in the correct. So in order to avoid just visually distinguishing which is which, A9. Yeah. Also, I tried to put them in order as well. Yeah, probably that went wrong, but doesn't matter. So eventually, I've written another little Python script just to create. Oh yeah. So see here, I had these lists in the wrong order. So the move order here and the move order here is not the same. So no, I don't want to save this. So eventually, what I needed to do here, I needed simply to sort both lists, and eventually I have this like results. Okay, and now just visually same that move that kind of available in one case and not available in other case. So this E7 G9, or this was the move where the bishop was kind of jumping over a piece. So that's how I revealed the bug. Yeah, so thanks to Chameleon, without that engine it would be really hard. And thanks to, my god, if I could quickly find the engine that was, maybe, I don't even remember. Yeah, I should have fixed that, but oh my god, what a fantastic, no, it's definitely not that. So yeah, I don't remember where did I find that, to be honest. So maybe somebody asking perfed. Nope. Sorry guys, I just don't remember where I took that. I should have stored that and give a credit to the guy, but actually the repository was empty, so there wasn't any engine. There was just like guy took the spurt results from somewhere and put them into his GitHub repos README file. So whoever you are, thank you very much for doing that. So now we can be happy with having this valid perf results, fortunately. And also the engine that is passing this perf result, not only Wukong, but also somewhat a different engine. So I guess this is it from my side regarding these bug fixes. Starting from the next video, we're going to be quickly adding functions, essential functions to build up the move generator altogether, and then we'll go for perf testing. So we'll see how Canon in particular is doing all of this perf testing stuff. So I hope that would be quite pretty exciting. And then really lots of job would be left. So kind of two directions. So the first one is actually the search and evaluation. Then connecting that to, I didn't yet take a decision, so whether we first will draft a simple GUI to test within our own web GUI. Probably that's the better way, because it would be possible for more people to play around with the code, because it's a little bit too tricky to deal with the GUIs for CNC. That's a little bit of a pain for now. And then probably come up with UCCI version. And also another thing that is absolutely essential, so we'll need to add a Zobrist hashing to our chess engine. So we would be incrementally updating the Zobrist hash keys to detect repetitions, because this is absolutely crucial. We can't allow perpetual checks in CNC. I'm not sure in particular yet how exactly we would be implementing that, so probably need to reference some sort of existing source codes. But anyway, I think that the most difficult part is now behind, because coming up with a bug-free move generator is probably one of the most essential things when you're writing a chess engine, regardless of chess variant. So this is it from my side, guys. I hope to see you in the next video. Until that time, and take care.